Okay, let's take a look at how to control a door. So say we have a big like loading bay door, dock door. We have some general sequences that it needs to go through here. Okay, that's important. We want to momentarily press the up button, causes the forward contactor to turn and stay on until the bay door is open. Okay, so it's going to be running and opening the bay door. And conversely here, momentarily pressing the down button causes the reverse contactor to turn and stay on, closing the bay door. Now the key word here is momentarily. That means that we have to put a ceiling in our ladder logic, and we'll cover that again when we get to it here. Pressing stop at any time causes the motor and the bay door to stop immediately. Okay, that's our E-stop, which is down here. Alright, the PLC uses two switches to detect, or two limit switches. Okay, we're going to detect when the bay is fully open or fully closed. Alright, and we're going to use these inputs and outputs. So we really have two buttons here. We have an up button and we have a down button. These are the addresses that we want to use. We have our emergency stop, which if that guy's not going, obviously it's not going to be going at all. And we have our two limit switches. One's telling us that the door is opened. The other one's telling us the door is all the way down at the bottom and closed. And we have the outputs. Okay, the door is going up, the door is going to be going down. That's the controls for it. So let's take a look at our first scenario here. Alright, let's draw the forward, or going up. Okay, the first thing we need to do that's important is pressing stop at any time causes the motor and the bay door to stop immediately. Okay, so we have to know that that guy's got to go first, because that guy's important. Okay? Now what we need to know is, this sounds a little backwards, but we're going to use a normally open contact here. So we're going to call this I0.1. Okay, and this is our E-stop. Now this might seem a little backwards, but it's not. Emergency stops are normally closed, but we want to be able to close this button, okay, to turn it off. So when you write your program, this guy is going to be energized because physically on our trainer, our 870 trainer, our E-stop is wired closed. Okay, however, but we want to hit the E-stop button, okay, to shut it off. So we're going to, for all purposes here, everything we're doing in our Siemens programming, we always going to use the E-stop as a normally open contact. However, it is wired normally closed. Okay? So that's very important. So we want to actually hit the switch, okay, to open the E-stop if we're talking hardwired. But for our purposes, we're going to use it as an open contact. Okay? Now, what we need to do is what? Have our forward, or our up, call it forward, but our up, okay, that's running. And for up running, that's when we hit the start button. So that's going to send the garage door up. So I0.0 sends our garage door up. Okay? And then we have to do what? The E-stop button and the up button have to be in place in order for our door to go up. Okay? So this is technically the start button here, if we're looking at our diagram over here. Alright? The door goes up, and this is Q 5.0. All the addresses I'm using is for the 87 iOS, the interactive piece with the stations. You're going to wire them separately to your stations as we go. Alright, so we got most of this going, right? Pressing stop would kill it, and we have the up button that sends it up. And what we need to do is, remember that part that says momentarily pressing up? Well, we've already covered ceilings, so we need to add a ceiling. That ceiling has to tie to this output, right? Because we want to hit that button, and we don't want to have to sit there and hold it. We want to be able to hit that button and keep this guy on, okay? So what we want to do is we want to put our ceiling here. Our ceiling is going to be the same as this guy. And I'm sorry, I wrote 5.0. This should be 4.0 because we're using the 87 iOS, okay? Let me rewrite that. So this is Q4.0, and I called this is the up door. we have our seal-in right here. So that means that this contactor is going to be called Q4.0. Okay, this is our seal-in. Okay, that means that the second we hit, when the e-stop's going already, the second we hit the up button, this is energized, which energizes this switch. So as long as this guy stays energized, we're going to get the signal through here, because we closed this contact because it was momentarily started. Okay, this contact's not going to open back up when we let go of the up. This is why we have an OR here. Okay, so this is our seal-in. So even if the up has been released and it's open now, this guy's still closed because it was originally charged, so the path is now this way through our ladder. Now we have to do one other thing. There's a limit switch, right? This would just mean the door's going to run forever and ever and ever and ever and not stop. We have to have something that makes it stop. Well, in order for us to stop it, okay, we use our limit switch over here. So I'm going to take that little piece out of our logic, and this means what? Our door is open. That's this limit switch right over here, switch 1. So I'm going to go ahead and place that in. But what's the point of this guy? The point of this guy is to shut him off, which means he should always be on. Okay? So we're going to call him normally closed. Alright, this is I 1.6. I'm getting that from down here. Okay, this is switch 1. This is switch 1. Okay, we want this guy normally closed, right? We want it to always work until it hits the limit that we've set, and then this guy needs to open. When this guy will open, that will de-energize the door from going forward. Okay, so now we've just written the control for the door to go up over here. Now we want to write the controls for the door to go back down. Well, everything still applies, right? We have to still hit the e-stop if, say something runs under the door, we don't have those sensors in, but that might be a scenario. We have to be able to detect, is the door all the way down? And we have to do something that makes the door go down. So really, if you're not familiar with the loading bay doors, think of the same exact thing of your garage door in your house. Okay? So this is going to be the same exact setup here. Okay, this is still our e-stop. That's our fail-safe point here. So I 0.1, and next we have, okay, this is our down. Okay, so this is our push button down over here. So this is I 1.1. Okay, we need our seal-in. Our seal-in is going to be based on what we call our output over here. But note this circuit's going to be the same. So this is down over here. Okay, which is really going to click on until what? This guy opens. This guy is our limit switch that tells us the door is closed. So this guy's normally closed, and this is I 1.7. That's from down here. So when it hits this switch right, he'll open. But we want him closed all the time so that we can energize this output, or this motor over here, that's going to be the door down. And this is Q 5.1. Okay, that's the door down. And I need to label this guy. This is our lock-in now. Our seal-in is based on this, right? We hit this button once, we want the door to continually go down. We don't want to sit there and hold the door over and over and over until it goes down. Okay, so this is our seal-in. So this will work. The door will keep going down until it hits this limit switch. The limit switch opens this contactor and turns it off. And pretty much that's it. That's how we control the door. We tell it to go up or down with our sensors. This is what it takes here. So here's our inputs, our outputs. Here's what they are translated into ladder logic. Okay, this is the e-stop. Remember, this guy is wired normally closed. Here's our buttons. Whether we want to make this guy go up, that's this contactor, or we make it go down, that's this contactor, so this is I1.1, I0.0. We have the seal-in for both of these. Remember, the seal-in is what makes the motor constantly go, because I just want to press this once. This seal-in kicks in once this guy is energized. Okay, and it will always run until this guy opens. Okay, when we hit that limit and this guy opens. And that's it.